Right here we have two advanced technologies to achieve those goals. One is a dissolved ozone flotation unit, and the other one is electrocoagulation and electro-oxidation technologies. Both allow deeper treatment on wastewaters and the removal of several micropollutants, micronutrients, antibiotics, hormones, difficult organic molecules. Those are the contaminants which are difficult to treat nowadays and require to be removed from the waters. Even looking at the future regulations in Europe and around the world that will be much more stringent for industries to comply with. Dissolved ozone flotation is a technology very similar to dissolved air flotation that allow, besides the separation, traditional separation of sludge, going a little bit beyond on oxidation processes due to the strong oxidative power of ozone that allows to remove these remaining organics that are still in the water. Combination of dissolved ozone flotation with other technologies, even biological technologies, will allow us then to move into a next step for water reuse. Electrocoagulation is a different application. Electrocoagulation uses electricity in order to give an extreme oxidative power to the water. Our effluent, our wastewater, works at a saline solution, so it's a conductivity solution, and the combination of an electrical current plus ion current plus the water hydrolysis allows us to remove heavy metals, to remove organics, to remove difficult molecules very easy on a very low OPEX cost. Electrocoagulation with the application of electrical current through electrodes that are immersed into the tank, the reactor, will generate effect that will remove all these, break down the molecules and produce a chemical precipitate with metal ions without the use of chemicals. So it's a more sustainable system than the traditional chemical treatment because we don't have chemical usage, because we don't require pH regulation, we don't require such a large amount of sludge formation, and it's a much more effective way of treating waters and removing, suspending and dissolved contaminants. From electrocoagulation, we can then add the traditional methods of sludge separation by settling or by flotation. And if we add a dissolved ozone flotation to an electrical coagulation system, then we have an extremely strong application that can remove the most difficult molecules. We have several examples around the world of application either of DOF, dissolved ozone flotation, and electrocoagulation, alone and together. We can even combine these systems with biological treatment plants because ozone will not affect the biological activity downstream. Electrocoagulation neither, so the compatibility of these with biological treatment systems is perfect, and we can have improvements, we can retrofit, we can increase the efficiency of existing plants by introducing these elements into existing processes because they can be modular and they can be fitted into existing plants.